Hello friends, welcome to Ramu Lakkapragada. ఈరోజు సిగ్నల్స్ అండ్ సిస్టమ్స్ ఇంపార్టెంట్ క్వశ్చన్స్ చెప్పబోతున్నాను. ఫర్ ఎగ్జామ్కి వీడియో కనుక మీకు నచ్చితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేసుకుని పక్కన బెల్ ఐకాన్ ఆన్లో పెట్టే నేను పెట్టి వీడియో మీకు నోటిఫికేషన్ అప్లోడ్ వస్తుంది ఫ్రెండ్స్. ఇప్పుడు టాప్లోకి వెళ్దాం. Signals and Systems Unit 1. Explain the classification of various signals. Explain how a function can be approximated by a system of orthogonal functions. Define orthogonal functions. Give some examples of orthogonal functions. Define and sketch the following elementary continuous time signals. Unit impulse signaling signals, unit step function. Differentiate between energy and power signals. Mean square errors. Explain the concept of orthogonically and orthonormatically using related expression. Explain the term completely orthogonal set using representing expression. Define the error function while approximating signals and hence derive the expression for condition for orthogonality between two waveforms f1 of t and f2 of t. Discuss the orthogonal signal space and obtain the expression for mean signal error. Define systems and its classification. Next, unit 2. State and prove time convergence and time differentiation properties of Fourier transform. State and prove differentiation and integration properties of Fourier transform. Define the Fourier transform of the signaling function and port its amplitude and phase spectrum. State and prove the following properties of Fourier transform: time shift, convolution in time domain. Discuss the concept of trigonometrical Fourier series and derive the expression for coefficient. Explain how Fourier transform is developed from Fourier series. Obtain the Fourier transform of the following function: impulse function, DC signal, unit step function. Define Fourier series and derive the relationship between trigonometric Fourier series and exponential Fourier series. Determine the Fourier transform for double exponential pulse whose function is given by y of t equal to e power minus 2 of t. Also drawn its magnitude and phase spectrum. State and prove the Peirasimo theorem. State the properties of Fourier series. What is a arbitrary transform and give its importance. Also state Peiras's theorem. State the Dirichlet conditions and explain any three properties of Fourier series. Obtain the Fourier series configuration A0, An and Bn. Define arbitrary transform. Find the complex exponential Fourier series coefficient of the signal x of t equal to sin 3 pi t plus 2 cos 4 pi t. Next, find the trigonometrical Fourier series from the periodic signal x of t. Show the below. X of t దగ్గర ప్రాబ్లం కనుక్కోవాలి. నెక్స్ట్, obtain the trigonometrical Fourier series from the half wave rectifiers sine wave as given below. ఈ సైన్ వేవ్ దగ్గర x of t అనేది కనుక్కోవాలి హాఫ్ వేవ్కి. మళ్ళీ ఈ యూనిట్లో ఉన్న ప్రాబ్లమ్స్ కూడా ప్రాక్టీస్ చేయాలి ఫ్రెండ్స్. యూనిట్ 3. Explain the characteristics of an ideal LPF. All ideally filters are physically not reliable. Justified. Obtain the relationship between the bandwidth and rise time of ideally low pass filter. What is an ideal filter and find the impulse response of an ideal low pass filter. Derive the relationship between bandwidth and rise time. Explain how impulse response and transfer function of a LTI system are related. Explain the briefly deterioration of periodic signals in the presence of noise by correlation. Explain the briefly extracting of a signal for noise by filtering. Define an LTI system. List the properties of LTI systems and explain. Unit 4. Correlation topic friends. Define the following properties for a continuous time system. Cause or non-cause, time variant or time invariant, linear or non-linear, stable or unstable. State and prove the relationship between covalent and correlation. State the properties of autocorrelation function. State and prove the relationship between rise time and bandwidth. Explain the filter characteristics of a linear systems. Prove the autocorrelation function and energy SAS power spectrum density functions forms Fourier transform pair. With an example, explain the graphical representation of covalent. Derive the relationship between PSDS of input and output for an LTI systems. Obtain the conditions for the distortionless transmission through a system. So that the autocorrelation function at the orthogonal origin is equal to the energy of the function. Find the response of an ideal low pass filter with unit step signal is applied as an input. What are the requirements of a system to allow the distortionless transmission of a signal? Define autocorrelation and cross correlation. Prove any two properties of correlation function. Find the Fourier transform of correlation cross correlation of f1 of t and f2 of t. What is an LTI system? Explain its property. Derive an expression for the transfer function of an LTI system. Obtain the conditions for the distortionless transmission through a system. Prove that the autocorrelation function and energy spectrum density functions forms a Fourier transform pair. Write notes on the distortionless transmission through a system. State the properties of covalence. What is the impulse response? So that the response of LTI system is covalenced, integrating of its impulse response with input signal. Explain the difference between the following system: linear and nonlinear system, time variant and time invariant systems. Explain about the LTI systems by taking an example. Discuss about the causality and response reliability of a system. Explain the relationship between autocorrelation function and energy or power spectrum density function. Explain cross correlation and autocorrelation of function. Discuss the properties of correlation function. State and explain the Perezo's theorem. Discuss the properties of correlation function. 4th unit lone sampling theorem. Explain the alternating how the signal is raised construction forms its samples. What is the different classification of sampling? Explain each within each sketch. State and prove the sampling theorem for a band limited signals. State and prove sampling theorem for band limited signals using graphical approach. What is the assigning? Explain its effects on sampling. Explain the differences between various sampling techniques. Explain the importance of sampling theorem. What is erasing and how it is avoided? Unit 5. Distance between one side and two side jet transforms and it is region of convergence. Define Laplace transform of signal x of t and its regions of convergence. List the advantages and limitations of Laplace transform. Find out the Laplace transform of the signal shown in the below figure. Laplace transform find cheyali. State and prove insert value and finite value theorems of Laplace transform. List the advantages and limitations of Laplace transform. Find the inverse z transform of x of z using power series method given x of t equal to 1 by 1 minus a into t power minus 1 into z greater than y. A. Prove the scanning and time shifting properties of Laplace transform. X of z equals z by z plus 2 into z minus 3. Find the inverse z transform of when the ROC is to z greater than 2 or ROC is to 2 greater than z or equal 3. State and prove initially and finite value theorems of z transform. Given the relationship between Fourier transform and Laplace transform, find inverse z transform using rescheduling method of the following. X of z equal to 1 plus 3 into z power minus 1 by 1 plus 3 into z power minus 1 plus 2 into z power minus 2 into z greater than 2. Find the inverse Laplace transform of x of s equal to 5s plus 13 by s into x square plus 4s plus 13. Re of s greater than 0. Find the signal s of t and the corresponding to the Laplace transform. X of s equal to 3s square plus 22s plus 27 by s square plus 3s plus 2 into s square plus 2s plus 5. What are the fundamental differences between continuous and discrete time signals? Explain the properties of the region of congruence of x of z. What are the methods by which inverse z transform can be found out? State the properties of ROC of the Laplace transform. Find the Laplace transform of the following signals. Impulse function, unit step function A sin omega naught t into u of t. Distance between Fourier transform, Laplace transform, Z transform. State and prove the time shifting and continue time convergence properties of Z transform. Find the inverse Z transform of x of z equal to z by z of z minus 1 into z minus 2 whole square. State and prove time convergence property of Z transform, Laplace transform. State and prove the following properties of Z transform. Linearity, time shifting, differentiation. Find the inverse Z transform. X of z equal to 1 minus 1 by 3 into z power minus 1 into 1 minus 1 by 6 into z power minus 1 to RCO z. Find the Laplace transform of following. T into e power minus at into u of t cos omega naught t into u of t. What is the relationship between LT and FT of the signals? State and prove the following properties of Z transform, time shifting, correlation, covalence. Explain the linearity and time shifting properties of Laplace transform. Find the Laplace transform of 2 t into u of t. List any two properties of ROC for Laplace transform. Explain the properties of ROC for Z transforms. Explain the scaling and the frequency shifting properties of Laplace transform. Find the inverse Laplace transform of Z of s equal to s plus 4 by s plus 3 into s plus 2 minus 3 greater than SES greater than minus 2. Explain the concept of ROC in the Z transform and list any two properties of the same. Find the inverse Z transform of x of z equal to z by 2 of z square minus 4z plus 1. Derive the relationship between Z transform and Fourier transform and practice all the problems in all units. Ununit lone problems and practice on. All the best for the exam.